Can you imagine that a celestial body 10 billion light years away from the Earth can be 1,000 times brighter than the entire Milky Way? According to common sense, the farther away you go, the fainter the light. But its existence is not a star or a galaxy, but a luminous object powered by a supermassive black hole. Scientists call this kind of celestial body a quasar. It is called a quasar because it looks unusually like a star in a telescope. However, in reality, it is extremely far away, and the energy it emits far exceeds that of stars, and even entire galaxies. Tang 618 is one of the most massive quasars that humans have ever observed, with a brightness of 140 trillion times that of the Taiyang. Its core black hole is also the largest black hole known to mankind, with a mass of 6 billion times that of the solar mass. Someone may ask, since it is a black hole, and the black hole itself is black and does not emit light, why is it so bright? We know that black holes have a very strong gravitational pull and will constantly swallow up the surrounding gas, dust, and even stars. These swallowed substances will form a huge spiral disk around the black hole. It is also a suction disk. The material in the suction machine tray will produce extremely high temperature due to high-speed rotation and mutual friction. The temperature of the suction plate of SUP 618 is as high as 150,000 degrees, which is 3 times higher than the surface temperature of the Taiyang. Here, the matter is no longer a fixed form, but is ground into a plasma stream close to the speed of light by gravity. This high temperature will cause the suction disk to emit a large amount of electromagnetic waves, including visible light, ultraviolet light, and X-rays. The total brightness of these electromagnetic waves is the brightness of Tang 618 that we observe. So, the light we see is the heat radiation produced by the black hole when it engulfs matter, not the black hole itself glows. According to the observational data of NASA, the mass of its core black hole is about 6 billion times the mass of the solar mass. How outrageous is this number to the bottom? The supermassive black hole in the center of the Milky Way, a Sagittarius, has a mass of about 300,000 times the mass of the Taiyang, and Tang 618 is 15,000 times more than it, and the Taiyang system, which we are proud of, is not even a speck of dust in front of it. Looking at the volume again, the volume of a black hole is a test of the sword, which is the Schwarzschild radius measurement. The Schwarzschild radius of Tang 618 is about 195 billion kilometers. What is this concept? The distance from the Earth to the Sun is 500 million kilometers, and its radius is equivalent to 1300 days away from light. It would take 47 days to run around its edge. This means that the light we see now was emitted 400 million years ago, when the universe was still in its infancy, and that Tang 618 may have undergone a great transformation. It may even have been stopped and become dim and dull. Why was the universe able to form such a huge black hole in the early stages? Astronomers are currently speculating that it may have originated from the original black hole, which is the seed black hole formed shortly after the explosion. In the early days of the universe, these primordial black holes frantically devoured the surrounding matter and gas, growing at an extremely rapid rate, and finally became supermassive black holes. SUP 618 is one of the representatives with the fastest growth and the largest model. This also explains why it was able to possess the terrifying mass we see today when it was still very young in the universe. The discovery process of Tang 618 is also very interesting, 1957 years. French astronomers discovered the special object during radio observations at the Tonantzintella Astronomical Observatory in Mexico. Because it is the 618 radio source discovered by the observatory, it is named Tang 618. Astronomers in early radio telescopes, it looked like an ordinary star, but the radio signal was unusually strong, which made scientists very bitter. Because the radio signal of ordinary stars is usually very weak, the radio signal of Tang 618 is stronger than that of the entire galaxy. With the advancement of optical telescopes and radio telescope technology, astronomers have uncovered its true identity through spectral analysis. They found that the spectra of Tang 618 had a very obvious red instrument, and the red meter value was as high as 219 E. According to Hubble's law, the greater the redshift value, the farther away it is from the Earth, and at the same time, it means that the faster the celestial body moves. Through redshift calculations, it was found that Tang 618 is about 104 billion light-years away from the Earth, and is an extremely distant celestial body. Subsequently, astronomers further observed that its brightness changes unusually drastically, and it will produce obvious waves over a period of days to months. This drastic brightness change only occurs in quasars, and the brightness change of ordinary stars is usually unusually slow. For example, it takes decades, or even centuries, for the Sun to observe a significant difference. It was finally determined that Tang 618 was a type of iron, its core. In recent years, with the use of equipment such as the tail-thin and the Grand Telescope, scientists have become more precise in their observations of Tang 618, and they have discovered more details, such as its tin-based disk structure. These observations not only further confirm its quasar status, but also explain the growth rate and attack mechanism of supermassive black holes in the early days of the universe, and then infer the distribution and evolution of matter at that time. In addition, the material in the suction plate is at the extreme end of high temperature, high pressure, and high magnetic field, and the physical laws here may be completely different from the ones we are familiar with. By observing the radiation of its inhalation disk, we can also study the physics of plasma in the extreme environment, gravitational theory, and even test Einstein's general theory of relativity. From then on, we continue to improve our understanding of the universe and the laws of matter, and finally answered the questions that the two great families could be concerned about. First of all, it is not the brightest celestial body in the universe. Gamma, the moment of the ray report, the brightness is higher than it, but it is better because the brightness is sustained and stable. Secondly, it will not swallow the entire universe. Although the mass is huge, the gravitational range is limited, so the Earth that is far away will not be affected by it.